everyone, and welcome to this webinar here. My name is Kevin Schrader. I'm the Technology Evangelist for Zend Technologies. I would like to thank Michelangelo Van Dam for coming here to talk a little bit about unit testing with Zend Framework. So Michelangelo, take it away.
Well, thank you, Kevin, and welcome everyone. Good morning, good afternoon, and good evening for everyone here attending this webinar. Let's start with the show because I know everyone is very excited about it. First of all, my name is Michelangelo Van Dam. I'm an independent consultant. I'm also a Zend certified engineer, and I'm president of the PHP user group PHP Benelux. You probably have known that we had a conference, and basically what we do is we try to bring best practices to everyone. So if you are in the Benelux region, come and join some of our meetings or our conference to learn more. All right. This webinar or this session is basically an sequel to my first presentation, also given here at the Zend webinars. My purpose here is because people were asking about more detailed introductions to how to set up unit tests for particular cases. So if you want to look it up, this is the site where you can find more about the framework. It's recorded at Zend, so it's easy to find. First of all, my question I often ask to the audience is, are there any reasons not to test? And the most common excuses I receive are, there's no time for it, there's no budget for it, the development team knows how to code but does not know how to test it. And the most common excuse is also tests are being provided after delivery. And everyone knows that's not going to happen. In my opinion, there are no excuses. The reason why it is if you are developing applications, what you see is that you start off with a budget, you start off with bugs. And all of a sudden you come to a point, the first milestone, where you say, well, we need to fix some bugs as well, but we still need to continue with our development. And we see that the increase of the expenses keeps on going while the majority of bugs are not being solved. If you start off with unit testing at the beginning, you will see that the expenses will keep on rising because there is more effort put in the project, but not as much as you would have without the unit testing. And the more unit testing you have, of course, the less bugs are likely to arise. So you keep your bug count low, your expenses relatively low, and you make better results with your coding. Because unit testing is all about maintainability. First, during development, test that fails is often an indication that you have a bug. Of course, you fix the bug, the test will succeed, and you know it's fixed. But also for after-sale support. I mean, everyone who's doing web development these days is not just writing some code, delivers it, and never looks back at it. So you have to do some after-sale support. So when someone comes around and says, well, we have this problem, you need to do a test to make sure that the issue is really a true bug and not something that the user did wrong on the system. So if you have a test already in place, if you have a test suite already in place, making an additional test is a piece of cake. And fixing the issues is most likely not to break the code base. But if it does break the code base, you know immediately and you can fix it. But also for long-term projects, and I'm talking about the projects you do often within the company, those projects, they last for several years. and sometimes the business change, so your project needs to change. And with unit testing, refactoring your code base is a whole lot easier, because once a test is made, it will always be tested. And in my book, that's for the win. Another great thing about unit testing is the confidence. First of all, for the developer, the code works, and the developer can prove it. For the manager, how he sees that the project is succeeding. And for the sales, general management, shareholders, everyone that has a direct financial impact because of it, they know they're going to make a profit. So they're happy. And in the end, the customer, well, he pays for what he wants. And you know he's getting what he's asking for. So in my book, I like this very much. But this is just an introduction. Let's get our hands dirty. I think that's why everyone is here, right? Unit testing Zend framework apps. First of all, we need to set things up. And we start easily by having a configuration file for PHP units. I'm using PHP unit because it closely resembles all the unit test suites that are being used for other languages, like NUnit for .NET, JUnit for Java. And PHP unit follows that same structure. And PHP unit is fairly easy to install. Have a look at phpunit.de, and everything will be explained in detail how to set it up. I use an XML file because I don't want to have all the configuration parameters on the command line every time. So I have put everything in a PHP unit XML. First of all, we create a test suite, we give it a name, and we give it a directory where to start. If you're developing Zend framework apps, you have an application folder, and you want to include all the PHP files in there. You might have your own library, so you want to include that as well. Depending on your need to test Zend framework, you can include it. I leave it out because Zend framework itself is fairly good tested, so I don't want to waste any CPU cycles on that. We know it's good, that's why we keep on developing applications with it. Another thing that you might want to exclude is the PHTML files, because those are views, and as a view they should not contain any logic. Maybe an iteration, but that's it. You don't need to include those in your test suite. So this is a fairly simple layout of how you can start using PHP unit. And with this configuration in place, all you need to do is type PHP unit in your test directory, and you're good to go. I'm also using some form of a bootstrap. I call it test helper. It's more easy to call it bootstrap, so you know exactly what it is, but I'm always a little awkward in these things. So I define a base path, application path, test path. That's easy for referring to my test cases, and my application environment. I explicitly set it to testing, so I know I'm always in a test environment. Always make sure that you set the default time zone. In my case, that's Europe Brussels. Have all error reporting on, and then you go require Zend application, create a new application, and bootstrap it. For those who are paying attention, I'm not going to run my application because we're just testing it. We don't need to have any response back from the application. And this is really, really a great addition. Since 1.11.4, Ralph Schindler, he's the developer at Zend on Zend framework. He provided a component in Zend tool that immediately creates PHP unit XML, the bootstrap PHP, and an index control in this case when you create a new Zend framework project. And for every controller that you make, it will include another test case in your test folders. So if you ever get to meet him, just shake his hand and say thank you to him, because he makes your life a whole lot easier. So with ZF Create project, you immediately have a complete setup for unit testing. So with this setup, we're good to go. So I say start your engines. And let's start with a very simple testing. Let's start testing Zend form. Everyone that sees this form on a website knows what the purpose is of this form. You provide your name, your email address, your website, and you provide a little comment, and you post it. Excuse me. So this is fairly easy to approach. So let's start off with the test. We extend from PHP unit framework test case, and we have a form. We set it up, and we tear it down, and that's our setup for the unit test. Of course, we want to make sure that good stuff can be submitted. So we have John Doe, we have Matthew Wirofini. The reason why I put in Matthew Wirofini is because his name is often a problem for forms. With the O apostrophe, that's not always accepted. Sometimes it's filtered out, or it's completely rejected. So I call it the MWAP test. If it passes, you know it's good. Same thing goes for DK Casey. He's from Blue Parabola. He also has a very unique structure in his name. He has a dot in it. He has a comma in it. So if that passes as well, you can do a monkey dance and be happy that it all passes. So in order to use that data, because this is just returning an array of information, we annotate with a data provider annotation. So we have this form accepts valid data. We have the 4 elements that we want to pass through, and then with the data provider annotation, it automatically fetches every element in the array that's being returned. And all we need to do is assert true that this form is valid. So that's fairly easy, right? But we also need a little bit of protection. There are people that have little Bobby tables as kid's name, or even worse, and I just see that my title is wrong, that they even have like security flaws, and that can cause a lot of havoc on your website. So you don't want that. So let's put in some bad stuff as well. So first of all, here comes empty strings. Little Bobby tables comes in second. Let's see if we can go over 100,000 characters. And we also want to have the mouse over exploit. The beauty of this is that as soon as you have a new exploit, I mean this is dating about 2010. Every day new exploits are being discovered and found. you can just add it to this array and make sure that even the newest exploits are not breaching your website security. If you have done the filtering correctly, you know you're good, and you don't have to worry. So you have the data provider with bad data. Same thing as with good data. You pass it through, and you assert false that the form is valid. Of course, this code will not succeed because we don't have a form class. So we create it, and we leave it empty. And when we run the test, we see that it failed. So let's put in some elements. And for those who are not familiar with ZenForm, this is a very simple approach where you have this add element in the initialization of your form with the type of field, a name of that field, and then of course some parameters regarding that field, like a label, if it's required or not. And with this, you have a very simple way to create form elements. And once this is done, you actually have a working form. So, are we having less errors? Yes, but there's still one failure. Our click exploit is still accepted, and we don't want that. We need to do some filtering and validation here. So we add the filters, and as you can see with the name, we actually have a validation MWOP. It's extending the alnum filter and validator, so you can use it basically to filter out the characters that are being accepted, like dots and commas and dashes. Further all, well, it's not really that complex. It's filtering and validating your form elements. If you want to know more about it, check out Zend Filter and you will see immediately what I'm talking about here. So when you have all the validators and filters in place, you go for the green, warm, and fuzzy feeling. So you're a winner. The quality code, check. Everything tested, check. Is it secure? Check. Is it reusable? Check. So it's fairly simple to create some tests, create your form object, and you're good to go. But applications exist more out of models than of forms. So let's have a look how we test our models. There's one thing to say about models is that they contain your logic. That's tied to your business, tied to your storage, and tied to your resources. And there's no one-size-fits-all kind of solution. So for every model that you create, you need to figure out, okay, what am I creating here and what am I doing here? So let's look at they contain structured data, populated through setters and getters. They perform logic tied to its purpose, like transforming data, filtering data, validating data. They can convert into other data types, like arrays, strings, JSON, serialized XML, or could be providers to other models. Using the form ideology that we had, we have a comment class. So it has an ID, a full name, email address, website, comments, and so on and so on. So we have a bunch of setters and getters, and of course we have a generic populate method, so we can just throw in a row of data and it populates the model. And we also have toArray and toString as methods to convert it back to as an array or to a string. Writing the model test is fairly simple. So first you set it up, you tear it down. We test that the model is empty at constructs, so you can assert null on many of the elements except the ID. That should be an integer null. But the test won't run because you still don't have get ID, set ID, and so on. So you need to create it. So create a very simple model, application model comment. I know it's a little pushed together just to get everything on this single slide. But this is basically your concept. You have setters, you have getters, and that's about it. You have the population that will set everything, and you're good to go. We start the test, we pass the test. Are we really passing the test? The reason why I'm asking this is because not all data comes from a form. Nowadays, data comes from databases, web services, hosted by ourselves or hosted by someone else. We even have CSV files. Take, for instance, license plates. They are pictures taken by a camera that provide us data. And you don't want to have a SQL injection caused by a license plate, do you? So we simply test it. And we use the same approach as we had with our forms. So first it goes in the good stuff. We have good data, yada, yada, yada. We test the model accepts the valid data. Again, the same approach as we have with our form. Only this time we're also looking that we can populate our model, because a form is populated automatically, and this is tested by some frameworks, so we don't need to worry about it. But this is our own model, so we need to test it. So if we cannot populate it, we need to fail, because we don't want the exception to be triggered. And then we verify that we have all the elements there. Same thing goes for the bad stuff. Again, little Bobby tables, the exploits, and some other stuff goes in. And let's run it. Ooh, we still see some failures. That's right, we haven't filtered and validated our model objects. So if you take a look at Zend filter input, you can actually use the same filtering and validation methods you have in Zend form and apply it into your models. Basically what we have done is we skipped the filtering validation in the form for most of the part and left it over to the model, because why you do things twice, right? So we create a filter array, which is like the element that you want to filter, and then the filters that you want to apply upon it. So ID, full name, email address, website, and a comment. Again, also the validators. You can have the string length in it. Again, the validation of MWOP, email addresses, callbacks, so you can verify URLs, and that's it. You populate it. Of course, you need to set your ID and the name, the email and the website, and of course the comment. And then you run it. And now we are really, really good. So my point is basically also do not take a green line or a unit test that just works. Say, okay, it works, move on to the next. You have to know what you're doing. So if you're building a model, make sure it can accept only valid data, and make sure that invalid data is rejected in some sort, and test that functionality as well. But now that we have the data, we need to store it somewhere. And there's a whole debate going on, and I'm not going to interfere there. I'm just showing you how to, and you decide on your own what to do with it. Everyone calls it integration testing, because you're testing database-specific functionality. Triggers, constraints, stored procedures, shortening scalability. Also verifying the data input and outputs, so you have correct encoding of data, transaction or execution, rollback is possible, that kind of thing. And that is specifically for every database vendor that's out there. So some say you don't need to do it because that's part of the database section. If you're really focusing on delivering quality, it doesn't hurt to do a little of this testing in there as well, just to be sure that everything works as you expect it to work. There are points of concern, specifically for several database vendors, auto increment sequence IDs. You cannot predict it. They sometimes generate those at random, or they're not set at all, or whatever. Also, current timestamp. If that's a default value, that might screw things up when you're doing testing, because you cannot really predict when the test is run, especially if you have it like continuously run on a CI system. So you need to make sure that your testing elements, you have a knowledge of what their value is going to be, and not what automated or randomly is generated. There's also a big difference between timestamp and datetime, UTC and local time. So we once had like hours of trying to figure out why something didn't work, because our system was developed for UTC while the server was still running local time. And we got some difficulties with the offsets there. But again, it all worked out. The domain model, it's nowadays a very common model. It has a model object, a mapper object, a table gateway object in most cases, but it can be a connection to any kind of data storage these days. NoSQL storage, cloud storage, CSV files, web services, you name it. I can highly recommend this book if you don't know it yet. In order to use database testing, we need to modify our test class. So we have it extend from PHP units framework test case, and we now have to extend it from Zend test PHP unit test database test case. And most of the things are okay in that model, so we don't need to modify a lot there. We do need to set up our database. So we have our application INI, and we can bootstrap the database resource. and create a mock on top of it. So we use the engine and we have the outputs mocked out. Then of course we need to have an initial data set, and that's why I call it an initial data set XML. I use a file, makes it easy for me to set things up. And the file looks a little bit like this. So that you start with a data set. The comment, the first element is your table, and of course the key values are the field values, and the values are the field, the actual data that you're going to run upon. So with this, you actually have a database comment table with two elements. Running a select statement or testing a select statement is very simple. You do a query on the data sets, and you can have the statement right in your query component there. So you expect a returning result set. Again, you use an XML file. Makes it easy to compare both and make sure that the data sets are equal. So this is what we expect as a result from our select statement, which is identical to the initial data set. Of course, we can also test updates. So we modify the comments. So I like you picking up the challenge, and we do the updates dataset XML. We do a comparison against that. So we have the comment changed, and this is what we're expecting. Testing delete. So we use the delete statements from the comment. So we expect at least one element to be in the database instead of two. So that's our delete dataset. And of course we have to be able to insert. Can add a comment. So I add another comment to it, and we're good to go. So our add data.
Stop you for a second. It doesn't seem like the slides are advancing.
Is it not?
Doesn't look.
Okay. Sorry about that. So I'm going quickly over this. Setting up a database with the mock object. So you can mock your database connection. It uses the database engine from your application configuration and mocks it out, and then you use a flat file as initial dataset. Initial dataset XML with two rows in it in the comment table. Selecting tests is just loading an expected dataset after a select statement on your mock object with the same rows. Update. What I do is I change the comment on the first element, and I load the expected dataset, which is still two rows, but the comment of the first one is different. Delete. Same thing. I look for the first row object. I delete it, and I compare it against my initial dataset, and this is what I expect. Insert statements. I expect now 3 elements in it. So if I run my test, ooh, I get a failure. What went wrong here? First of all, the auto increment. So we need to filter out the ID. So we can have a dataset filter, and that allows us to filter out the ID from the result set. So we modify our insert data set because we expect now 3 rows without an ID, and when we run the test, we're okay to go. Let me go quickly over the web services, as I see I don't have too much time left. Web services, it's easy. You have to comply with an API, and that will also be your reference for testing. Most of the time, you don't always have the opportunity to make a test call, like paid services per call, the test environment is offline, network-related issues, and so on and so on. So what I'm going to show you is a very simple way to test web services and know that your application is compliant with the API. I take, for example, join in. It has a complete description of the API. So all you need to do is create a join in test case that allows you to connect with the service and make sure that you can test the feedback that you get. So can I get some user details? Can I check the status? And those are very simple tests. But when we run it, we get some failures. First of all, we already logged in another time, and it means that we have a different last login time, so we cannot work with that. There's also that the connection that we need to make to the web service and the return response takes about a second. It's 1 second off, but there's nothing you can do to prevent this. So a better approach is that you take the API, mock out your HTTP client, and use the Zend HTTP client adapted test, which allows you to load responses in. So this is the response that you expect from the web service, and you set it to your client, and then you can run your tests. Very simple and very smoothly. As you can see, it takes less than a second. So if you have a lot of web services you need to test, you don't need to test the web service itself, as long as you just test the functionality. There's one downside: if they change the API without you knowing it, your tests are still succeeding, but your application is not. So you need to build some form of checking to make sure that the API is still compliant. And if you're paying for it, if they change it without your knowledge, well, then they have to give you some money back, as I say. Controller testing, in my objective, it's not really an essential part of your application, but it's still required to do so. So let's go over our form flow. We start with a form, we validate it. If it's not valid, we return back to the form. If it's valid, we store it, success, and then we stop. Setting up controller test is fairly easy. You just extend from Zend test PHP unit to controller test case. And like I said, if you create a new Zend framework project with Zend tool, it automatically creates the first controller test case for you. So verifying that a form is on a page, I mean, it doesn't really give you a lot of benefit, because if this is more something you leave to Selenium or something like that. There's more knowledge in verifying that if you send data to it, it's processed correctly and that you get redirected to a success page, or that you get redirected to a failure page or back to the form with error messages on it. That's more practical to be using. You can use data providers again to test validator and to test invalidator, but we already know that's taken care of our model. So leave the checking of the controllers for error messages in the form, or to see that we are redirected back to the home page. Running the test, fairly quick, and testing it all. All is green. We know we're good, and it gives you a nice progress report. So my conclusion is, unit testing is simple. Combine integration test with unit test. Test what counts and mock outs what's remote or expensive. Thank you, and you can find me on IRC or on Twitter. And if you tweet about this webinar, use UT4ZF as feedback, and I will pick it up. If you have questions, I address now to Kevin to see what the questions are.
All right. Thank you very much. We have a couple of questions here. The first one was from John. I think that he missed a little bit about the data provider. Could you just go over, talk a little bit about the data provider again, because I think that he had missed some of that. Because actually, that was something that I myself wasn't that aware of, which I actually found quite interesting. Would you be able to just cover the data provider in a couple of words?
Yeah, the data provider is an annotation that you can use in PHP unit, and it's the parameter that you put behind the annotation data provider is basically the method that returns you an array of elements. Every element is an array, so you always start with an array of items. And if you have just one element, like a first name, that you want to check, you just provide it the first name that you want to test on. If it's like another collection of elements, you need to embed it again in an array. But every element itself is run once. So if you have a data provider with 4 arrays in it, that means that it will run 4 times. So every element will be tested independently from each other. So it's not like I'm going to populate a collection with four elements through my data provider. No, it's going to populate it with just a single element. So you can test your collection, but it still contains just one element.
Is that something that you would kind of recommend, where you just simply always use a data provider so you can easily add more elements onto there, or just kind of do it on a case-by-case basis?
Well, especially if you want to do valid and invalid testing, I think data providers are great. Especially the example with the Twitter hack. Now you have like 10 exploits, but you can keep on increasing the amount of exploits just by adding a new exploit if it comes around. Just add it just one line to your data provider, and you're good to go. So you don't have to put a lot of effort in maintaining it because you just need it on one place.
Cool. Next question for ZF apps or ZF apps for the Europeans. For ZF apps, is it better to move configuration code from index.php to the Bootstrap class so you can more easily test your application?
The index.php should only set up your environment and boot everything up to your application. It should be just a single point of entry. Just set up your environment and shoot off to application. All configuration stuff should be set in your application INI and, of course, your Bootstrap.
All right, and The next question here, how would you mock controller dependencies, such as DB objects, from the outside?
Oh, that's a tough one. If I want to mock out DB objects from the outside, there's not an easy answer to that. Most of the time, I mock out the database connection component, or I mock out the web service connection client, so to speak, and I can use my own methods basically to provide it with services or functionality that I need on that particular moment. If you really want to cherry pick components out of a connection and mock those components out, you need to create your own mock object, and with mock out methods that you can switch on and off as a configuration in your setup of your test application. I hope that is satisfying as an answer. Otherwise, pick it up on Twitter with the UT4ZF hashtag, and I will pick up the conversation from there.
All right, next question, which is totally an easy question. Is it viable to retrospectively add testing to existing medium to large scale applications, and where do I start?
Where do you start? First of all, it doesn't matter if it's a big application, if it's a small application. Starting unit testing is always a good thing. Even for a small application, it can benefit because you don't know if that small application is going to grow. For big application, if it doesn't have a unit test, it's better to start late than never. And where do you start? Look at what is the most important part of that application. What is making you money? Start there. If that application, that part of the application is failing, you or your company is losing money, and that's not a good thing. So start with the most important part. Where do you lose money? And work from there outwards to what are the nice gimmicks to our customers. It doesn't provide us extra money, but it's nice to give to our customers.
All right, next question. Are there any existing resources available that will tell you how to allow unit testing of login or registration forms? I guess the question is there anything additional in terms of testing login or registration forms that people need to be aware of?
Well, if you Google, most of the time you end up on either SlideShare or on forums. There's a lot of documentation about testing Zend form on the Zend framework website in the manual, and of course these slides I picked up a lot going to the conferences and see Matthew and Mike talk about the bowling game and unit test it. And those are the most common resources for that. As you can see, I have this code on GitHub, so you can download it and play around with it. That's basically what I know of resources. If you find some, make sure that you notify me, and I will add it to this slides.
All right, another question here. Which version of PHP Unit does Zend Framework 1 support?
Well, I use 3.4.15 at this moment. I know 3.5, some of it is working with Zend Framework. 3.6 causes a lot of issues. But Zend Framework 2 works with 3.6. So if you run applications both on Zend Framework 1 and on Zend Framework 2, you need to install both PHP units side by side.
Right. Another question here. What is the advantage of using the ZenDB test case instead of the original PHP unit DB test case?
I used the ZenDB test case because I was able to connect it immediately with my Zen framework application structure to get my resources. If you use the PHP unit DB test cases, you need to extract that information yourself and fetch that resource out of your application and install it as a component mock object in your DB test cases. It works the same way. The Zen framework DB test case extends from ZenDB, but it allows you to easily hook up on your application and retrieve the resource immediately out of your application.
Next question here. Are there ways to automate testing in a defined period of time, and is it possible to have a browser view?
Yes. For the first question, automating unit tests, you can use a continuous integration platform like Jenkins CI, or there are several CI systems out there that support PHP. And what it does, every change that you make to the code base, or if you set it on an interval, it will automatically run the unit test on that new code base. So it will show up nice reports saying these are the tests that failed, these are the tests that are okay. You can automate this. A browser view onto this unit testing, no, except for what you get as a report from a continuous integration program, because the report is actually more important than running the unit test itself.
And if you're looking for a browser view, wouldn't something like Selenium or some other kind of, more?
Yeah, if you really want to test the web application from a browser point of view, I definitely recommend Selenium.
Right, we've got 3 minutes left, which means I'm going to give one last question here. And the question is, how could you test a doctrine class in here?
Gosh, I was never in the luxury that I could test a doctrine class here. But I expect that the doctrine classes are just models like the models that I showed here. So if you know what kind of methods they have and what you can provide to that methods, you should be able to test it. And doctrine itself is an application, and if I'm not mistaken, they have a full test suite attached to it. So if you really want to know how to test your doctrine classes, start looking at the unit test of doctrine, and they will tell you exactly how it works internally.
I know I said that was the last question, but there's actually an interesting one here that I think would be good to cover, and this one will be the last question. Basically, is it a good idea, and if so, how would you test Zend view helpers as opposed to testing the view itself?
Zend view helpers are classes themselves. The view object that you pass in can be mocked out, and it's basically just reusable logic that you put in the view helpers. So consider it a normal class, and if you expect that as a response from that view, you should be able to test it.
Cool. All right, that brings us then to the end of our time. I would definitely like to thank Michelangelo for being here, or Michael Mago, if you look at the way you spelled it. Michael Mago. Yeah. A bunch of people got a kick out of that. Thank you for joining us. For our attendees, This webinar was being recorded, so it will be available on Zend.com at some point. You can follow us on Facebook. Just type in Zend Technologies into your search bar and we'll come up, and we'll be posting the link to this webinar there. We'll also be posting it on Zend.com. You can follow us at Twitter. You can follow Michelangelo on Twitter. He's got his Twitter handle up running. Just go, and for our Twitter handle is just go to twitter.com/Zend. And we would love to hear from you, and we definitely would thank you for attending the webinar here today with us today. So have yourselves a good day.
Yes, and thank you for being here, and goodbye to everyone, and thank you, Kevin, for having me. It was a pleasure.
Glad to have you. Anytime.
All right.
Take care, everyone.